let's get started. Let's talk about T-SQL itself. We'll get started actually creating some queries, and then let's add some constraints or some limits. Now, with T-SQL itself, you have a database, okay? And you have you, or an application. And you, or the application, needs to get data out of that database. The data is arranged in whatever way works for the Relational Database Management System, the RDBMS. So it's stored in certain pages with certain amounts of sizes, and it's arranged in various tables and databases and whatever. You need to access this data, and the way you do it is through a high-level language called Transact SQL, or SQL, or Structured Query Language. So between the user, which can also be an application or a process, we use SQL to talk to this database and retrieve data or put data in. Here we have the database engine, and we use Transact SQL not only running what we're going to do, ad hoc queries, but we can also use Java, Microsoft.NET, PHP. There are a variety of different applications that can use T-SQL in the application to talk to the database, because the database does not speak Java, it does not speak .NET, it does not speak PHP, it speaks SQL. We have the SQL database engine here in the back end, and we can talk to it using T-SQL with any of these applications, Java, Microsoft.NET, PHP. You can write scripts. You can do it from a command line if you want to. We're going to be doing ad hoc queries at the query window. But the thing is, SQL Server, the database, does not speak Java. It doesn't speak DOS. It doesn't speak PHP or .NET. It speaks T-SQL. Whenever an application or a person needs to get data, you're going to use T-SQL. So we can have T-SQL in the application, in our batch file, at our command prompt. But we don't try to speak some programming language to it. We speak this high-level language called T-SQL. And yes, we do call it sort of a code, but it's not quite exactly the same code as if we were developing applications. It is a code for talking to the database. With Transact SQL, we have statements, but there are three types of statements. There's the data definition language, the DDL, which we use to create things. Whenever we create tables, we create databases, we alter these tables, we delete or drop these tables. So when we create, alter, delete objects, we are using data definition language, DDL. Data manipulation language, DML, is to actually get the data out of those databases or tables. So when we do select statements, or we insert stuff, or we try to put in data into the objects we've created. We create the objects with DDL. We put in the data and get the data out with DML. DML is the one we're going to use the most. We want to retrieve data or put it in. Then there's a data control language, DCL, and that's where you grant permissions to something. You can set security settings. You can set settings on a table or a view. I grant you the right to see this, do that, something. We can do that in the SQL Management Studio in the security section as well, but we also have SQL statements to grant permissions or revoke those permissions as well. So data control language, DCL. This is the basic structure of a query in Transact SQL. We're going to run some kind of command, and we'll put parameters after that command. We usually specify the source with possible parameters, and there might be additional commands after that. So let's go take a look. Here is our Management Studio, and once you've installed SQL Express with tools, you can get the Management Studio just by simply clicking Start, and you'll see the Management Studio right here. If you don't see the Management Studio immediately, you can go to All Programs, and you can go down to MS SQL Server 2012 and expand that, and then you'll see the SQL Server Management Studio right here. So this is the Management Studio. When it installs, it's going to ask you, do you want to have a default instance? Do you want to have a named instance? An instance is merely that particular installation of SQL. you can have multiple instances running, meaning you can have multiple installations running side by side simultaneously. This is the idea of having multiple instances. You have to be careful. If you install this on your own machine, your own laptop or whatever to practice with, there's a very good chance you might already have an application that already uses SQL Express in the background. So make sure that the instance name is something different or original. Usually applications will name their instance of SQL Express after themselves. You can put in any name you like, and then make sure that you connect to that instance as opposed to some other application, because you'll be going, huh, what is this? It won't look the way you expect. So here I am, and I am connected to the default instance. I can always right-click up here, and I can connect to whatever I like. Right now, what we're going to do is we're going to take a learning database, and we're going to attach it. Now, the learning database is something you can get from Microsoft, or you can get from whatever labs or exercises you may have. But we're going to right-click databases, and we're going to attach. And when we attach database, we're going to click Add, and we're going to browse for something that was already downloaded. I'm going over here to Add, and I'm going to click it. And I'm going to browse, and this is something that was downloaded. And this is the AdventureWorks LT 2012 database. I'm going to just browse right into here. And notice that the database has a .mdf file extension. I just click this when I click OK. And down here, it will show the database and the log, which, by the way, if you download something from Microsoft and it doesn't have a log attached in LDF, just click the MDF. And if over here in the message it says can't find it or missing, you just select the log and you remove, and it'll create a brand new one for you, create a brand new log. Anyway, we've selected this, we're good, we click OK. And now when I open databases, I can see that AdventureWorks is one of these databases right here. Now let's actually take a look at SQL, and let's look at some of the statements. We see the basic structure for T-SQL, and here's an example right here. We can select, and the very first thing is when you select, you are retrieving or getting something. We're going to select. Now the next thing is, what is it that we're going to select? In this example, and we're going to build up to it, don't panic yet. In this example, we are getting something called employee ID, and that's going to be one column in a table. And then we're going to get the first name, which is another column, and then we're going to get the last name, and we're going to get the age. Now notice that each of these columns is separated by a comma. So give me this, 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 and this information about something in that table. What table? Well, the next thing is, what table are we talking about? From the employees table. So I want the employee ID, first name, last name, age, from the employees table. In our database, we'll have many tables. Employees is one of those tables. And then I see that where, now I'm going to have a condition here. I don't want just everybody. I want them only if the age is greater than 40. In other words, from the employees table, everybody who's over 40, I want their ID, first name, last name, and age. And then, don't give it to me in just a mess. Please rearrange it. Order it by last name. So you're not going to see anybody who's under 40, and you're going to see them arranged by last name, starting from A down to Z. Now, the reason why I'm showing you something that's a little bit complex to begin with is to understand something about SQL. When you issue a command and you hit execute or F5 or go in a batch file, SQL does not go line by line. It does not do this line, then this line, then this line, then this line, then this line. What it does is it examines the whole command, the whole query, and figures out an execution plan based on the whole thing. So it'll usually start out with the table. Okay, the employees table. And now what? I need to get this, 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 and this. Oh, and I need to only get it if it satisfies this. And before I present the results, I need to organize the results. This order by is just organize the results. So this query will not just go line, 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 line like this. SQL will figure out the best way to do this, to execute this, usually starting with the table itself. This has implications further down the road when you have developers who are writing SQL statements and they're writing the code. There are a lot of different ways to maybe accomplish the same thing. But sometimes you write something one way and it just doesn't perform as well as if you were to write it a different way. And as the database administrator, we can use SQL tools to see, well, this one takes a lot less time than that one. And we can go to our developer and say, hey, this one has kind of poor performance. Can you kind of rewrite this a bit? Knowing that SQL will figure out its execution plan ahead of time helps us understand that SQL doesn't just simply go line, then line, then line, then line. And it helps us in the future understand what we can do to help tune these things. If we're just doing some small queries against a table with a couple thousand records, you never notice the difference. But when you have millions of records, the difference can be huge, and I'm going to talk about that later. So here's our order of operation is not just line by line. Our order of operation will start with the employees table. Okay, let's look for everybody who's over 40. Get me this information about them, and then finally sort it out and give me a sorted response. Here's an example of data definition language, DDL. I'm going to create something. I'm going to create some kind of object, create a table, create a database, create a view, create an index. And then I give it whatever name and then add whatever parameters I like. Here's an example right here. Create database, test DB. Now notice the little semicolon right here. Semicolon means that this statement is done. And you can go ahead, SQL, and figure out how to execute it right now. When you're writing code, when you're writing batch files, when you're a developer, you'll probably have many, 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 many statements separated by semicolons. When we're doing simple ad hoc queries like this, you don't need to have the semicolon, but it's a good practice to get into. Let's actually try it here. We're going to create database, and we're going to call it test DB. Now, by the way, SQL is not case sensitive unless you tell it to collate case sensitive, which in standard SQL it is not. Let's actually try this now. So I've created my statement. If I press enter, I'm going to press enter. Notice that my carriage return just simply goes to the next line. It doesn't actually execute. If I want to execute, I have to either press F5 or I have to go up here and click execute. I'm going to press F5 right here, F5. And I can see now, we'll just expand this a bit, that my command completed successfully. And when I look over here, I see that I have AdventureWorks as a database, but let me refresh my view. Often this thing needs to be refreshed. In fact, you won't see anything new unless you refresh it. So I'm going to right-click and I'm going to refresh. And I'm going to open up databases again. And there's test DB. So we've had our first introduction to the structured query language. Now let's really get farther into creating select statements and creating objects.